Introduction.
Good morning, teacher.
Good morning, students. Today we learn haloalkanes and haloarenes.
Ma'am, what are haloalkanes?
Haloalkanes are the chemical compounds in which one or more of the hydrogen atom in an alkane have been replaced by halogen atom.
And what are halogens, ma'am?
Halogens are the reactive nonmetals having 7 valence electrons. So now, can anybody tell me what haloarenes are?
Yes, ma'am. Haloarenes are the molecules in which halogen atoms are bonded with carbon atoms that are a part of an aryl ring.
Very good, Rohit. In this lesson, we learn more about haloalkanes and haloarenes. Objectives. At the end of this lesson, you will be able to classify haloalkanes and haloarenes, discuss nomenclature of alkyl halides and aryl halides, give a brief on nature of CX bond, describe different methods of preparation of alkyl halides and aryl halides, describe physical properties of alkyl halides and aryl halides. Classification. Haloalkanes or alkyl halides are the compounds which have the general formula Rx, where R is an alkyl or substituted alkyl group and X is the halogen F, Cl, Br or I. Haloarenes or aryl halides are compounds containing halogens attached directly to an aromatic ring. They have the general formula ARX, where AR is phenyl or substituted phenyl. Haloalkanes and haloarenes may be classified on the number of halogen atoms. They may be classified as mono, di, or polyhalogen compounds. Polyhalogen compounds include tri, tetra, and so on. Classification. Classification of monohalo compounds on the basis of hybridization of carbon atom as given below. Halogen compounds in which halogen is bonded to sp3 hybridized carbon. Alkyl halides or haloalkanes Rx. Their general formula is CnH2n plus 1x. They are further classified as primary haloalkane, secondary haloalkane, or tertiary haloalkane according to whether the halogen atom is bonded to primary, secondary, or tertiary carbon atom. Allylic halides. In these compounds, halogen is bonded to allylic compounds, that is, to the sp3 hybridized carbon atom and next to a carbon-carbon double bond. Benzylic halides. In these halides, the halogen atom is bonded to a sp3 hybridized carbon atom next to an aromatic ring, that is, to a benzylic carbon. Classification. Halogen compounds in which halogen is bonded to sp2 hybridized carbon. Vinylic halides. In these halides, halogen is bonded to one of the carbon atoms of a carbon-carbon double bond which is sp2 hybridized, that is, to a vinylic carbon. Aryl halides. In these halides, the halogen atom is directly bonded to carbon atom of the aromatic ring. For example, halobenzene. Nomenclature. The common names of alkyl halides are named by naming the alkyl group attached to the halogen and adding the name of the halide. In our UPAC system of nomenclature, alkyl halides are named as halogen-substituted hydrocarbon. Haloarenes are termed as aryl halide in IUPAC as well as common or trivial system. For dihalogen compounds, ortho and meta, para are used as prefixes in common or trivial system, but in IUPAC system, 1, 2, 1, 3 and 1, 4 numerals are used. Nomenclature. The dihalo compounds having the same type of halogen atoms are classified into geminal halides and vicinal halides. When two same halogen atoms are attached to the same carbon, then they are called geminal dihalides, named as alkydene halides in common name system, and they are named as dihaloalkanes in IUPAC system. When two halogen atoms are attached to adjacent carbon atoms are called vicinal dihalides. They are named as alkylene dihalides in common name system, and they are named as dihaloalkanes in IUPAC system. Nature of CX bond. A halogen atom is more electronegative than carbon atom, so the carbon-halogen bond of an alkyl halide gets polarized. The carbon atom retains a partial positive charge and the halogen atom retains a partial negative charge. As the size of the halogen atom increases down the group from fluorine to iodine, the carbon-halogen bond length increases from CF to Ci. Methods of preparation. From alcohols. Alkyl halides can be prepared from alcohols as shown in the chemical reactions. There are various ways to produce alkyl halides using thionyl chloride, and is quite convenient method as the other products SO2 and HCl are gases and are easily expelled during the distillation, leaving behind pure alkyl chloride. Methods of preparation. From hydrocarbons. By free radical halogenation. The reaction of a halogen with an alkane in the presence of ultraviolet light or heat leads to the formation of alkyl halide or haloalkane. By electrophilic substitution. Aryl halides can be prepared by the electrophilic substitution of arenes with halogen in the presence of Lewis acid catalysts such as iron or iron 3 chloride. Methods of preparation. Sandmeyer's reaction. When an aromatic amine dissolves in aqueous mineral acid treated with sodium nitrate, a diazonium salt is formed. The formed solution is mixed with cuprous chloride or cuprous bromide, which replaces the diazonium group by Cl or Br. If we replace the diazonium group by iodine, then instead of using cuprous halide, we use potassium iodide. Methods of preparation. From alkenes. Addition of hydrogen halides. Alkene is converted to specially alkyl halides by reaction with hydrogen halide. Addition of halogens. On mixing bromine in CCl4 to an alkane, it results in the formation of Wick dibromide. Methods of preparation. Halogen exchange. Alkyl iodides can be prepared by reacting alkyl chloride bromides in the presence of dry acetone. This reaction is also called as Finkelstein reaction. The alkyl fluoride can be prepared by Schwarz reaction, in which alkyl chloride bromide are heated in the presence of metallic fluoride. Physical properties. In pure form, the alkyl halides are colorless, and bromides and particularly iodides develop color when exposed to light. Melting and boiling points. Due to the polar nature and high molecular masses as compared to the corresponding hydrocarbon of organic compounds, the intermolecular forces of attraction that are dipole-dipole and van der Waals are stronger than the organic halogen compounds, due to which the boiling point of chlorides, bromides and iodides are higher than the hydrocarbons of approximately an equal molecular mass. For the alkyl group, say R, the decreasing order of boiling point of alkyl halides are Ri has the highest boiling point, followed by Rbr, then Rci, and then Rf. Melting and boiling points. For isomeric alkyl halides, the boiling point decreases with branching. This is because branching of the chain decreases the surface area and consequently the intermolecular forces of attraction. The boiling points of isomeric dihalobenzenes are nearly the same. The melting points of isomeric dihalobenzenes are quite different. The melting point of the para-isomer is roughly 70 to 100 degrees higher than the melting point of ortho and meta-isomers. The higher melting point of the para-isomer is due to its symmetrical structure, which makes it to fit better in the crystal lattice. Density. Alkyl chlorides are generally lighter than water, whereas bromides and iodides are heavier. The densities are in the order Ri greater than Rbr greater than Rcl. Polychlorides are, however, heavier than water. Solubility. The halogen alkanes are only slightly soluble in water. To dissolve alkane in water, energy is required to break the bonds between haloalkane molecules and water molecules. When bond is formed between haloalkane and water molecule, then very less energy is released, due to which haloalkanes are slightly soluble in water. Haloalkanes are soluble in organic solvents such as ether, alcohol and benzene because the energy released and required are the same. Did you know haloalkanes are used as flame retardants, fire extinguishants, refrigerants, propellants, solvents and in pharmaceuticals as well? Many halocarbons are serious pollutants and toxins. For example, chlorofluorocarbons lead to the depletion of the ozone layer over Antarctica. Summary. Let us summarize what we have learned. Haloalkanes are the compounds which have the general formula Rx, where R is an alkyl or substituted alkyl group and X is halogen, F, Cl, Br or I. Haloarenes are compounds containing halogens attached directly to an aromatic ring. In common name system, alkyl halides are named by naming the alkyl group attached to the halogen and adding the name of the halide. In IUPAC system of nomenclature, alkyl halides are named as halogen-substituted hydrocarbon. Alkyl halides can be prepared from alcohols, hydrocarbons and by halogen exchange. The boiling points of chlorides, bromides and iodides are higher than the hydrocarbons of approximately equal molecular masses. The boiling points of isomeric dihalobenzenes are nearly the same. The melting points of isomeric dihalobenzenes are quite different. The halogen alkanes are only slightly soluble in water.